Okay, sound check. All right, looks like we're rolling. So I thought today would be a really fun one. We have broken tests right now, and the reason is that we broke the function that makes a string from an array of characters because we were rewriting the array. So I thought it'd be really fun to kind of do a little bit of a red to green stream here. So let's pick one. Let's start with an easy one. So character escape, probably. We go zoom in a bit. Let's see what happens here. I think string from characters to do. So prelude. Yeah, of course. This is the guy. So we're actually going to rewrite our built-in string to be defined in the language. Very similar to what we just did for our array. Just to get back to green for now. This isn't our long-term plan for string, but this is where we're going to start. So I think the long-term plan has to have some notion of understanding how many bytes we want to use per character. Anyway, I'm really not sure. But I'm going to go type string, and the idea is to go length data. Like that. And see how far we can get. So we now have sort of all the features we need to treat this data. Has a multi-pointer to characters. And one thing you'll notice, I'm not attaching any type information to my pointers right now. The idea was that this type really does just talk about a memory address. And by not attaching a type to it, I was trying to make it very separate from the user level reference type, which is the thing that we would expect users to have and use and pass around and stuff. But I think it's bad. I think it's just lost information. We might as well let you attach a type to these. It would help. It would help out in a number of ways, and then also, I mean, even in the debug info, like we can't really tell LLVM what type this is, which isn't really a big deal, but we're basically just leaving information on the table that the programmer probably has and that we have. So even though this type is meant to just represent a raw pointer, I don't see why we shouldn't attach type info. And then we can always do the C thing where we want to actually use void star, but we would maybe say any or something. If you really want to say you don't know what you have a pointer to, I haven't thought yet too much. I don't have a great solution for how we're going to do, if there will even be such a thing as like a don't care type, or if there even will be an any type. But anyway, let's just move on this built-in string. If we can, just checking. We got things framed okay. All right. So everything is implemented in terms of intrinsic functions. Basically, these will become no longer intrinsic. Length will just be an accessor on the struct member. There is some argument to leaving this as a function and hiding the internals of the string. I don't want to start a holy war. But it would let the platform change how strings are represented without that being a breaking change. TBD. For now, let's say bye-bye. Okay, and I think this is going to be as simple as it's the same data. Are we really just ditching the capacity? Yep, we sure are. We have better ways to iterate now. I'm going to leave this alone for now. This could also be a memcopy. Let's try and make this a memcopy if we have time. Make sure things are big enough. I'm going to leave the file tree up just so that the code is, closer to centered. I was going to say. We can do something like this. Okay, these are our only 4. So I think we'll be good. This is my only intrinsic. Let's leave that intrinsic for now, and then we can look at what it does. I think it mem compares the contents, and I'm not sure if we get to use mem compare. I guess for parity we might as well do that for string equals. For now we'll leave it intrinsic. So let's do get. So really this is going to be let, and I know that this does not support Unicode. These are simple byte array strings. I'm gonna worry about that. I'm gonna worry about that later. There's gonna be self.data ref at index. And we need to say that we want a char. We might not. It can probably infer it from here. And we'll do the same that we did on array here. Do get ref. Now, you could make an argument for just saying, hey, a string is just array of char, but I don't want the capacity on it. And I think by default, strings being immutable is really powerful. You could even argue that like an intern pool is a good idea for strings if you're going to have a light runtime, which I'm kind of thinking about doing. But I don't really want to just make them the same thing. All right, let's run this. Type string exists. That's a pretty good error for mucking around with the internals. So I'm just looking for all occurrences of the string to see where I can kind of quickly get to the places we've hard coded this. I think now what we need is a type ID. Right. So if we look at Prelude, we kind of got to play this game of finding out what the type ID of string is going to be. Just because I don't really want to introduce a piece of state that tracks what it is once it sees it. So I think that if it comes after array, we're looking at 17. So the reason we have a skip here is because there's one for arrays t here, and then there's one for this struct. So array takes up 2, and then it actually gets created. The generic type array becomes 16. The string type ID then would be 17. Ah, okay. So I think we're going to have to decrement every these. Nice. And that'll create some errors now that we're never referencing string type. Oh no, we are. Okay. Yeah, so I have debug asserts. Oops, I have asserts on all of these. Da, da, da. Because obviously it would be a disaster if those didn't line up. It's just convenience to know what they are ahead of time and have it be a constant. So we have, this ensures that all those line up. And then we have one later for array. Yeah, it's this one. So let's go ahead, do the same for string. Fortunately, string's not generic, so this one will be a lot simpler. Is it it's a struct. It's a new type struct. So what I could do, I could make this an opaque alias. And what that would mean is you can't treat it as the struct from outside of its companion namespace. You have to interact with it via functions. And that would let us hide the implementation details, right? I don't really have any interest in doing that right now. I'm just going to make it a plain old struct. So by doing it this way, this is like defining a new type. It's not just an alias. This would be like that. And then this would be like TypeScripts, defining a type, where it's really just a name for what's on the right-hand side. This version without alias does a little bit more. It really does make a struct type that we could implement abilities for that has its own identity. It makes a type with a real identity called string that happens to be represented by this struct, if that makes sense. Not happens to, but is definitely represented by that struct. So that should be good enough for now. pause real quick because my machine's lagging. Seems a little better now, just OBS. OBS being OBS. Okay, so now we, oh, yeah. It should definitely have a def and info. All right, let's try compiling, see what we've got. Okay. All right. We're referencing, okay, a type does not yet exist. Ooh, the length is 14. The index is 16. So this is on get type. Types get no follow, which we only call in a couple places. So, oh, and typed module new. Okay. Okay. String does not go in here. Same thing again, I think. Len is 13, but the index is 16 at line 530. I don't have a line number for this because I stripped debug info so that my builds would be faster. Oh no, I just deleted the wrong. No, that's correct. String type ID. It's not gonna be. Yeah, it's not gonna be in there. Cool, we can't assert that one yet. We have to assert that one later because we haven't defined the type yet. Type string exists. Okay, but does it? Where do we even put that in root scope? Scopes make. I don't think I hard code things into a lot of scopes. Oh, type string built-in. These are the things that you just. I do such stupid things when I'm trying to make these videos. I'm sorry. Okay. Okay. It doesn't know. Right. So for the string intrinsic, it appears inside. I feel like that one should still work. Could not resolve intrinsic function type for function equals. So this is where we try and, if we see an intern function, we try to map it to our enum so we know which one it is. And then we carry along which one it is. So we look for where it's defined in its name. So, this is not the real one. This is the real one. So equals and type string. Okay, but this type is no longer so my right hand side self types get, yeah, so if the type we're implementing, we don't even have to get it. Ooh. Yeah, so but I do want to match on it for the structure of this code for the other cases. So we can do T. I don't think I can do if. See, so I'm trying to match on the type we're implementing the ability for, because I need that down here, but I don't really care about it here. This would just be struct, and then I would have to check its name to really know if it's string, so it's not really helpful. So this kind of wrecks the, I mean, it's already not exhaustive, so I think it's fine. This will never be an exhaustive match anyway, because it's trying to find a few things it cares about. So I think I'm happy with that. All right, that's true. And that passed. Let's try length 2. That fails. All right, so let's debug it. So what we'll do, I have a debug. I have a debug task. No, I don't. Okay. This is char escape. So we try to debug this. So we'll break it main and we'll run. So that was b main, tiny LDB lesson. This is all I know. We're gonna run. Okay, and there's our code. We're broken here. Now I'll go next, and then I'm gonna do v for print stack variables. And we see that c is \n. I guess I don't have any strings, so there's not really anything useful to print out here. So yeah, this is kind of a waste of time. Let's try and test a program that actually has a string in it. Let's see what's still failing. I thought they were all gonna pass. Char hello. Okay, so anything with dot length. So let's have you on the left, you on the right, and go through these. And I'm gonna try and pay some attention. Oh, fix me. This one was broken, but then it was fixed. So I fixed it without removing the fix me. I think I might just not have type string is not iterable. That's actually really neat. So now, oh, item type of iterable. Typer. Types. Okay, so iteration in the language is not in userland right now. What I did is I said, I just defined this function. This is basically tells us if a type is iterable. And if it is, then what type. So back when array was in here, then array obviously was, and it was its element type, and then string was iterable with character. This won't work anymore. Iteration needs to be, okay, well, I can still hard code it. Because what I can do, so the new array is down here. It's a generic. So I could find it. And I might go ahead and do that. And I might do the same for struct. If so, yeah. We can do this. Ooh, I need T. So I made this extractor called asArray instance, where if it happens to be not the generic array. If it happens to be an instance of the generic array, then here's its array type. Here's an array type, and all that has inside is the element type. And the element type is the first type param, so the value of T in array land. So I have this. So then what I can do, that would be some array type, element type, else none. So that is, but the problem is not for generics. I'm in the wrong place because those will actually be structs. So if array suddenly became not implemented as a struct for some reason, then this would break, which is kind of clunky. Okay. And what's wrong here? String not covered. Right. Well, string is going away, but I don't want to remove it just yet because I kind of like that our code is passing. Code is compiling. So that's fine. We'll leave that there. And now we need if the struct is string. So else. So it would be def and info. Some def and info. And the def and info we're looking for would be where the name is string, obviously, and the scope. Okay. If the name is string and the scope is root, then that's enough for me, I think. I'm just trying to decide what to fix this on. To know that it's the built-in string. The built-in string. For now, I mean, look, the grand plan would be to do an iterable ability. We have type classes and abilities, so eventually we'll do iteration with abilities. But for now, it's just gonna be a couple lines to keep things working the way they were. So yeah, let's do this. So since we're inside types, not our big typer module, we don't actually have access to the ID pool. So I think I might need to move this function out, or I could just pass in identifiers. That's not a global. So here's our for expression, the only place where we check if something is iterable. We now just need to pass identifiers. What? Not so bad. Just pass it in. Just pass the thing in. And let's see if they're iterable. Length, string length, right. So I don't know if I've fully fixed this yet. Right, so these should not be function calls anymore. This is going to be member access, struct, field access. Oh boy. So on the itery, that has to be box new. And the target field, that's len. Oh no. Length is first. It's len cap data. Oh no. Oh, if it's string itery, okay. So this is string len. So that's character, body span, iterable span. The whole 4x for span. Oh, that might fail borrow check. No, it's fine. Okay. Wait, is it? Let's just use the body span. Okay. And same for array length. Itery variable, len. Oh, shoot. What have I done? I've created a split. Okay. So this is just converting the generated code to access the length by member, struct member, instead of calling that length function. We also could have just kept the length function here to keep the API the same, but we didn't. Wow. That worked. Let's see if, so this is ASDF. So this is the ASCII codes for ASDF. Yep, that fails. So we did it. And now I do want to do a debug. So we can inspect the memory. So let's debug this. Debug for yield string. Okay, so we have S, length 4, data, ASDF, sign long. What are we at? 34 minutes. The length. Oh, it's uninitialized, yeah. So char codes is not available yet. The block expert val is not available. Yielded collection. So here's our output collection that will become char codes. Char code's not available, but yielded call is. This is the scope ID we're in. So the unique name. So you see length, capacity are 4. Now C as int. So as we go through this, and now if we v, we can see yielded call. Now, I don't think its length should have been 4. Its length should have been initialized as 0. So if I look at array new, I think that might be just a problem with our new. Oh no. Right, so this is actually not new. This is with capacity. And the length is 0, and this is actually the cap. So that might have broken some of my code, but that's an important thing to have caught actually. Because then what would happen here is if you then tried to just access the third element, it would pass and it would just give you uninitialized memory, which is obviously really, really bad. We could actually probably observe that. So if we do yielded call dot data. So let's print array 4. See, so 97, 115, 100, and then 0. That's uninitialized. 0 is lucky, right, to have gotten. And if we know that the type's defaultable, we could initialize it all to the default, but that's not, that's not what's happening here. So now if we print the array again, we see we got values. Now char codes is the same thing as yielded call 206. So now I could say, I think I could say char codes.data 1. Okay, P. That's 115. And 2 is 100. That is awesome. Okay. So case closed on that test. Let's keep on cranking. Oh yeah, that's right. We were going to walk through all the failing tests. 65 tests failed because we broke prelude. Assign array. What's wrong with assign array? Array new, and then we call set, and then we never set the length in our array literal. So now that length is 0 when we call new, and in my for got 4 expr, no, it's array literal. Array literal. So here is where we implement what's happening, this syntax, which desugars to something that I can actually print out here in a second. So let's do this. Here, and we'll do block to string, and this will be array lit block. Okay, so check this out. What file are we doing? Assign array. Let's run. So this is what it becomes. It becomes a block, which means it becomes its own lexical block. And inside there, let me paste it. This is what this code becomes. So we call new with 3. We set element 0, 1, and 2. We do not do so in a loop, right? In the machine code, this is not a loop, it's just unrolled because we have literals for each value. So I don't even know how you would do that. I don't know where you'd put the values. And yeah, so by the time we return this, because of what we just changed, the length is still 0. So we could call push, which I think is exactly what we want to do. Because if we look at push, whoops. If we have room, then yeah. So it's going to be an extra instruction to set the length for every time instead of just at the end, but that's going to totally get optimized out. So for now, let's call push. Which means we don't need an index expr. I have no idea what failed or where. Oh no. So that means we had no span. So I think I need to run this with trace. So this is a sign array. It's while parsing. Oh. Wonder why this didn't parse. Because I don't support this yet. Bear with me. This should work. Oh, because I don't even let users use this. So yeah, I mean, obviously the parser is not user-friendly at all. That's an entirely different project to make a parser that works and a parser that works well on bad inputs. Okay, we can't push because we don't have a pointer, which is fair. If we set the length, yeah, so to be fair, the desugared code probably should. I love we got the span right though. The desugared code probably should be. If I set the length instead of calling push, I don't think that it would save, so I do think it has to be a reference either way. So our array variable needs to be a unary op, taking the address of the array new call, and the type will be, oh no, the type will be unfortunately, we have to add reference type to the array type. And the expression, of course, the call to array new, and the span being the iterable span. Oh, do I just have? Okay, I just have one here. So what this does is it makes it it adds this operator. It adds an address of operator in front. That's it. It is going to be array new. And it's going to be array new. Expert, of course. This would make more sense to just do as a macro. You know, if you just imagine you had the time to build an entire macro system. You start to see why Rust does it as a macro, because it's actually a lot of code. I mean, this is pretty, I mean, it's a trivial amount of code in the grand scheme of things, but you do enough of this and you realize what you're doing is work that a compiler can do pretty easily, right? If you just had a simple like macro or rewrite system, like the act of outputting code that the user didn't write exactly. Anyway, this is all just an exercise. So it's okay if it feels a little silly sometimes. I think that's passing. And this is what we're generating now. So we now have an array reference, and we can call push with an array reference because that's what it takes. We return our arraylet, and everything is good to go in this test as well. We don't need this part anymore, and we don't need, but we could say array literal desugar. Why not? We'll leave that in as a debug for fun since it's new. And let's see how far we got. Oh man, we broke more things. Oh, because now it's the wrong type, right? So now we need to dereference it. Oh, so the final thing we yield is let switching deref array let. I'm gonna go grab my reference that I just made, uniriop, because it's pretty much the same thing but backwards, to dereference it. So this is going to be dereferencing this, and the type ID is going to be array new fun call type, the type of the actual array. Arguably new. Yeah, new actually should just be returning an array reference. Now that would be a reference to something that's on its stack, which it can't do. So I could do like the sret thing, secret output args, because it really doesn't make sense to have one of these. Well, it kind of does make sense to have one of these by value if you're not mutating it. But if you're mutating it, you always need it by reference. And I need to put semantics in the code that require that. We'll leave it by value for now. The caller can then take a reference to it to mutate it, which I think is what I'm doing in other code. Oh, you got moved. So we're going to do... Okay, that one was already passing. The question is, did we unbreak most of the rest of the code? Ability constraint, pipe, for yield string. Oh, so many failed. I thought this was going to be like a video where I just kind of crank through a couple of changes, delete a bunch of code, and then everything is passing. But it was not the case. Wow, this is a big test. Pattern matching. Unrelated pattern type string will never match string. That's actually a really good one. So the way to find the rest of the places that we're going to have to update to make stuff not be broken is actually now it is worth deleting this. So here's our types. The real win of making string now a struct is actually to do this, because now there's one less type in the language, and that just massively reduces, in my opinion so far, learning to work in these things, the complexity of the language. Every piece of code has to think about what it should do for every one of these types, so it's so nice to remove one. You know, I'm going to look at this closely and think of ways to consolidate. Tag instance is going away, so that's nice. That'll be one more. Pointer might just become... No, it needs to be built in. Anyway. We remove string. A lot of things are going to break. Let's just kind of walk through. So there's the obvious stuff. Here's handling built-ins. We don't need to do that. Here is substitute in type. It's just gone. Nothing we need to think about here. Here is eval pattern. So pattern matching. This is where we need to use our string type instead. Now, does this work because it's const? Will this actually match on it? Can I then use... Okay, no. It's not just giving the pattern a name, right? Okay. And now, right, we no longer need a special case for string methods. That's awesome. And constructors for type. It's now just a struct. Oh, no, but we do need to think about, because it has a special literal type and has pattern. So we remove this, but we need to replace it under struct. Ooh. See what I'm talking about here? So when you pattern match on strings now, by default, it's just going to be matching on the struct, which we don't want. So, and do we ever want someone to be able to match on a string that way? I don't think so. So here's a case where it is special. And now we can basically do if. Now, what was the name? Type ID. So we could handle string. Something like this. It's not as bad as it feels because this is still exhaustive. It's not great though. Where are the rest of my errors? In types and in code gen. Oh, a lot in types. That makes sense. It's just gone. It's not special anymore. And codegen LLVM. It's the only place we reference that string type. But we have all sorts of string code, which we will no longer need because it'll just be a pointer. We will still need special code to make string literals. I hadn't thought about that. Probably get some kind of crash. No, is pattern literal? Oh, it passed. No way. So whatever we're doing for string literals is just working. I think it's because our new representation, our old one match. So we're going to codegen. This would be typed expr string. No? Where's a stir? Okay. Yeah, so for a string literal, we make a global, and what do? We do data as an array of characters, I8s, and then we do a struct that's length data. Yeah. So it's working because we happen to represent it the same way. This needs to look up the actual string struct and kind of do the same thing, although it's going to have to end up being basically the same. It's going to have to assert that the shape is the same, and then maybe it can do things a little bit more in terms of our string, but it won't actually change that much because the literals are special. Unless what we wanted to do was to desugar that in the IR and make them not special, where a string literal would become like an array new or something. But I think I really like having them be actual globals in the LLVM because then they go in the actual binary and like a different memory space, right? Okay. What do we do? Okay, still a lot. Let's go to pipe. Prelude. Fun concat. There's so many failing that it's suspicious. Index of. Okay. Array of structs. Why is this one failing? Ah. This is just maybe been broken for array. Ah, no, this syntax was returning an array pointer. Yeah, yeah. And I haven't had this syntax passing yet. Ah, yeah, this is just an array. Cool. This is obviously not our final form. It's not what we want. To have to be doing that address of. Okay, I think you're fixed. Sure are. Array fill. This is new. int5. Access.set. I think it's just gonna say that set takes a pointer. Length. Okay. Oh, you know what? Set actually works because it just mutates the memory. Ooh. Oh, set doesn't push. Yeah, this is just bad. This is just bad code, right? I now have tests that kind of cover this already. I might just ditch this one or combine it. I can consolidate a number of these. What do we have? We have array int, array bool, array, yeah, array of structs. You know, this was a big deal to put a struct inside an array early on, so it makes sense. But yeah, maybe we collapse these into fewer. But for now, this should just be push. Oh, we're just pushing 4 every time. Wow, and then this isn't even iterating. Okay, that's not even right. This would be cap. Okay, now it passes, but it's stupid. So this is like, fix me. This test is stupid. Okay. I'm scared for why generic inference. Okay. That's not so bad. Turns out I was using array length a lot as like just an example-y thing. Okay, cool. Are you passing? No, I just ran the wrong file. Nope, you are not index out of bounds. Hmm. From chars bytes.len. So copied. Copied needs to have the right length, and it's not going to because new. So I like need you to be a pointer. And I need to be like, once I know I've set them all, I need to do this. Commit again. This is extra bad now since new. Okay. But do more tests pass. Hmm. What's going on with generic enum? Array index out of bounds. Oh. I think this has something to do with concat. You still failing? Yeah. We're malicking 6. That's correct. It's just really sad. It was really cool that I could do this with just the built-in functions back when I originally added it, but now it's just something that yeah, I really don't even want. We should just do I is less than new length. One loop. We're calling, yeah, we have to, this is just push though. This can just be push. And then it's at least a little bit more sound. And then for yield string, and for yield. Well. Something wrong with the 4xpers, I guess. Oh. What? You were passing. Oh no. Index out of bounds. You too? I wish I had the correct line numbers. What did I do wrong? Calling array new. Let's print our desugared code. So I guess this just means running with debug. We're so close. No, don't show me code gen. Show me. Oh, it's too much here. All right, so I gotta find this array literal thing again. Change that back to an ePrintln, and we're gonna run with out debug logging. Oh, right. This doesn't have an array literal, so I'm just barking up the complete wrong tree, huh? Oh, this is because for yield calls array new. And then it's calling set should just be calling push. All these programs had the ability to, I mean, I wasn't even doing bounds checking before, so I guess that's part of why I didn't care. Okay, so every time needs to be push. So this is going to be self, body, span, push. right. Array push. Whoops. Yeah, I fixed that. And we don't need an index. All right, we're yellowing it. We're gonna try the whole thing. I really thought I had it. What's wrong with you? Okay, so it's the exact same treatment. The thing needs to be referenced the whole time. Yielded call. Yielded call. Oh, that's weird. Oh no. Yeah. And then we're gonna have to dereference it. I am so close. I'm gonna declare victory there because we made this exact same fix for the other syntax. Once this is a reference, push will succeed and we'll be good to go. So yeah, that was, I think, a pretty successful adventure. If we look at the diff, a lot of this was removing stuff I did before. Yeah, that wasn't done as part of this video, so maybe the diff won't be that helpful, but yeah, we just removed the built-in type and replaced it with a user-defined type, and we're able to implement string entirely in the language itself, with the exception of support for literals and iteration at this point. Just basically because we have pointers now and a way of interacting with pointers and knowing the size of types. But still, that gets you a long way for being able to implement the low-level primitives in the source language. So I think, that's pretty neat. It definitely feels like a big milestone because when I first started this project, just the ability to get anything working at all, even if I baked it all in, felt like a huge win. And now the fact that I'm here, a year or two later, seeing the path towards making these things not baked in, it feels like real progress as far as the, my learning and the objective of the project, which is to kind of understand compilers better. So yeah, thanks for watching. Hope you enjoyed it. Fun one to make a lot of progress there. Changed a lot of code. So yeah, hope you got something out of that. Thanks.